All right, so this is our second lesson on modeling using linear systems. Our learning goal is still the same here. We want to be able to solve problems that can be modeled and solved using systems of linear equations. In the last lesson, we looked at what I called mixing type problems. And today we're going to look at problems involving distance, velocity, and time. So before we get into the problems themselves, what is the relationship between distance, velocity, and time? Well, the one to remember is that velocity is distance divided by time, or v equals d over t. Okay, and we can remember this by thinking of a velocity as being something like 100 kilometers per hour. So the velocity of 100 kilometers per hour is a distance, 100 kilometers per hour. The kilometers per hour means we're dividing, so 100 kilometers in 1 hour. Now, this relationship here, the velocity is distance over time, can be rearranged a little bit. We can multiply both sides by t to get that distance is velocity times time. Or from here, we can solve for t to get time is equal to distance divided by velocity. Now, of these three relationships, which are really the same relationship, but of these three expressions for this relationship between velocity, distance, and time, the one we often want to work with is this one here, because it's the one that does not have any fractions. And fractions make questions more difficult to answer, so we are going to try to avoid fractions when we can. Now, that issue is only going to come up in sort of a very small number of questions that we do. All right, let's get to our first problem here. Depending on the version of the notes that you have, this question may or may not be in there. So you might have to skip to the next question. This one involves Aurora driving. Some versions of the notes have the question with Maria driving. We're going to do that question next. So the question here says Aurora drove 500 kilometers from Windsor to Peterborough in 5.5 hours. She drove at 100 kilometers for part of the trip and at 80 kilometers per hour for the remainder. How long did she spend driving at each speed? So in this question, just like the ones we did yesterday, how long did she spend driving at each speed is sort of indicating what we're trying to find in this question and how we want to set it up. If they're asking us how long she spent driving at each speed, they're asking us for a time. So when we set up our variables, we are going to set up variables for the time. Now, our trip here is divided into two groups. Or sort of two parts. There's the part at 100 kilometers per hour, that's one of our velocities, and a part at 80 kilometers per hour. So as we go through this question, we're going to be thinking of it as having those two parts to it. So we're going to choose two different variables. We're going to let x be the time at our first part here, 100 kilometers per hour. And we're going to let y be the time that she spent driving in the second part of the trip at 80 kilometers per hour. Now, working with these questions on distance, velocity, and time, it's helpful to sort of set up a little table with our distances, our velocities, and our time to help us kind of pull the information out of the question. So we're going to have a column for each of the two parts of our trip. We're going to have this first part at 100 kilometers per hour. We're going to have a column for the second part of the trip, 80 kilometers per hour. And then we're going to have a final column here for the total. And this chart is going to help us get the equations that we're going to want to solve. So how far did she travel at 100 kilometers per hour? Well, it doesn't tell us in the question, okay? It does tell us that the total distance she traveled is 500 kilometers. That's from right here. So we can add that to our table as our total distance. And that's all we know for the distances so far. Let's see. What do we know about velocities? Well, obviously there's a velocity of 100 kilometers per hour here and 80 kilometers per hour here. Okay. And we don't really have a total velocity. What about time? Well, we know that the total time she spent driving is 5.5 hours. So we can add that under our total here, 5.5. What about at 100 kilometers? Well, we define that as x. X is the time she spent at 100 kilometers per hour. Y is the time that she spent at 80 kilometers per hour. Now this final line of our table here gives us one of the equations that we want to work with. If our total time is 5.5, then x and y, the time at 80 and 100, must add up to that 5.5. Now let's come back and fill in this last line here for our distance. We know from the previous slide that distance is velocity times time. So if we look at the 100 kilometer per hour column here, we know that her velocity is 100 kilometers per hour. The time is x hours. So an expression for the distance that she travels is 100 times x. Same kind of thing for the 80 kilometers per hour. She is traveling, distance again is velocity times time. The velocity is 80 kilometers per hour. The time is y hours. So she travels a distance of 80y. This gives us the second equation that we're going to work with. Okay? Because if I just take off these kilometers here, we can see that 100x plus 80y must add up to 500. So our system that we're going to solve are these equations right here. So how do we solve this system of equations? Well, I think we're going to use elimination here. We are going to take this first equation here, and let's try to eliminate, what should we eliminate? Let's eliminate x here. So to eliminate x, we're going to want to take our second equation here, and I'm going to multiply it by 100. That's going to give me 100x plus 100y equals, let's see, 5.5 times 100 is going to be 550. Our top equation here is 100x plus 80y equals 500. To do my elimination, I'm just going to subtract these two equations. The 100s cancel out, which is what I want. 100y minus 80y is going to be 20y. 550 minus 500 leaves us with 50. So dividing both sides by 20 gives us y is equal to 2.5. So that would be 2.5 hours. That's how long she spent driving at 80 kilometers per hour. To get our value for x, we are just going to take this equation, x plus y equals 5.5. We're going to sub in our value for y. And we're going to do that subtraction. Subtract 2.5 from both sides. We get that x is equal to 3. So we can sum it all up. That she spent, let's see, x is the time at 100 kilometers an hour. So we can say 3 hours at 100 kilometers per hour. And then 2.5 hours at 80 kilometers per hour. So we've answered the question that they asked us in the problem. All right. So there's our first example. Our next example is very, very similar. All right, this is the one involving Maria. This might be the first question that you have in your package, depending on the version. So Maria drove from Owen Sound to Ottawa, a distance of 550 kilometers. The trip took 7 hours. Maria drove at 70 kilometers per hour for part of the trip and 85 kilometers for the remainder of the trip. How far did she drive at 70 kilometers per hour? So what is the question asking us again? How far did she drive at 70 kilometers per hour? Okay, is what we want to find out at the end. And just like the last question, they've split the drive into two parts. We've got a part at 70 kilometers per hour and a part at 85 kilometers per hour. So we kind of can see how we're going to organize this by setting up the table, just like in the last one. The trick to this one is rather than, even though it asks us how far she drove at each of these speeds, we are going to want to use time as our variables, just like in the last question. And doing so will help us to avoid fractions. So again, let's pick a variable here for the time. We'll say let x be the time at 70 kilometers per hour. And let's y be the time at 85 kilometers per hour, because those are the two parts of the trip that we've got divided up here. And again, let's set up our little table here. Distance, velocity, and time. And we've got a 70 kilometer per hour section, an 80 kilometer per hour section, and a total. And let's work our way through the question here, figuring out what they've given us. Okay, so right off the bat, we've chosen our variables x and y to be the times. So we can put in x for the time at 70 and y for the time at 80 kilometers per hour. Okay, she drove from Owen Sound to Ottawa, a distance of 550 kilometers. That's our total distance. So total distance goes in here. The trip took 7 hours. That's our total time. Okay, so already we've got one of our equations here. X plus y equals 7. Maria drove 70 kilometers per hour per part of the trip, 85 kilometers per hour for the remainder of the trip. So those are our two velocities, 70 and 85. Okay, again, we don't have a total velocity because that doesn't really make a lot of sense. But just like in the last one, we can get expressions for the distance using distance equals velocity times time. So our distance at 70 kilometers per hour is going to be 70x. Our distance at 85 is going to be, again, velocity times time, 85y. And this gives us the second equation that we want to work with. Solving this one is going to be exactly the same as solving the last one. We have, again, our two equations here and here. We're going to want to use elimination. And so to use elimination, we are going to take our second equation here and we are going to multiply it by 70 to get the coefficients on x to match. 70x plus 70y equals 7 times 70, 490. Our second equation, we're just going to copy it from above. Now, what do we have to do to get, what do we need to do to solve this system using elimination? Well, we've got our coefficients on x matching up, so we need to subtract our two equations, because 70x minus 70x is going to cancel out and eliminate x. 70y minus 85y is negative 15y. 490 minus 550 is going to give us negative 60. And if we divide both sides by -15, y is equal to 4. We can take our value of y, sub it into our equation because we know x plus y is equal to 7. Sub in 4, and we get that x is equal to 3. Okay, so we know that x and y represent our time, so this is 4 hours, and this is 3 hours, our values for x and y. Let's go up and let's refresh our memory here on what they were asking us in the question. They're asking us how far did she drive at 70 kilometers per hour? Okay, so what they really want though is not the times, they want the distance that she drove at 70 kilometers per hour. Well, that's going to be 70x. So we'll say distance equals 70x. Our value for x is 3. So 70 times 3, that's going to be 210 kilometers. So that's going to be our final answer here. She drove 210 kilometers at 70 kilometers per hour. Okay. So those first two questions were kind of similar. Okay, we set up the table, position, distance, velocity, and time, and then we solved. Our next two questions are also similar to each other, but are slightly different from the one that we had here. So here, a small plane took 3 hours to fly 360 kilometers from Ottawa to Halifax with a tailwind. On the return trip, flying into the wind, the plane took 4 hours to make the same flight. Find the wind speed and the speed of the plane in still air. Okay, first off, what does it mean by a tailwind? Well, a tailwind is a wind that is pushing against the tail of the plane. So it is, pushing toward the back of the plane, pushing it forward. It's going in the same direction as the plane. It makes the plane go faster. Okay? So if the plane is going faster, it's like we've got the plane speed, and we're adding the wind speed to it to get the total velocity. Like our speed of our plane is increased by the speed of the wind. The other way around, we have a headwind. Okay? And a headwind is when the wind is pushing against the nose of the plane, or it's going in the opposite direction of the plane. So it's slowing down the plane because it's working against the direction that the plane is trying to go. So in case like that, our velocity is going to be the speed of our plane minus the speed of the wind. Our plane is slowed down by however fast the wind is going. Okay? Those two things are going to be crucial to solving this question here. So what is the question that they're asking us here? Find the wind speed and the speed of the plane in still air. So we're going to use variables to represent those two things. Let W be wind speed, and let P be the plane speed. And this is going to be the plane speed in still air. Okay? So these ones here would be P, and these ones here would be W. All right, let's set up a table, again, for distance, velocity, and time. And we've got two trips that we're talking about here. We've got the trip from Ottawa to Halifax, so we're going there. Okay? And then we have the return trip where we are going back. Those are the two categories that we have here. So on the way there, it took 3 hours on the way there, so our time is 3. The distance is 960 kilometers. Okay. And its velocity, well, let's see, on the way there, it's got a tailwind. So our velocity is going to be our plane speed plus our wind speed. So P plus W, because our plane is being sped up by this tailwind. On the way back, it still has to travel 960 kilometers. It's still the same distance. This time the trip is taking 4 hours. And instead of, if we're going the opposite direction rather than a tailwind, we have a headwind. So our plane is going to be going slower on the way back. So our velocity is the plane speed minus the wind speed. We can take this information that we have here and develop it into equations. And we can just use that distance is velocity divided by time. So on the way there, our distance, sorry, not distance is velocity divided by time, my mistake. I meant our velocity is distance divided by time. That'll work a lot better. So our velocity on the way there is P plus W. Our distance is 960. Our time is 3. Okay. On the way back, our velocity is P minus W. Our distance is 960. And our time is 4. These are the two equations that we're going to try to solve. So what are we going to do? This first equation, P plus W, I can just do 960 divided by 3 as our first step here. That's going to be 320. I can do the same thing with the second one. I'm just going to slide it down here. P minus W is 960 divided by 4. It's 240. Now I can solve my system by elimination. I just need to add these two equations together because my W's are going to cancel out. I got a negative W and a positive W. When I add them up, I get 2P is equal to, let's see, that's 560. Dividing both sides by 2, I get 280. That's my value for P. And if I want to solve for W, well, I know that P plus W is equal to 320. That comes from right here. So subbing in my value for P, which is 280, subtracting that 280 from both sides, W looks like it's going to be 40. So P is my plane speed. Which is 280 kilometers per hour. My wind speed, 40 kilometers per hour. And actually, I'll just write it over here. So it's kind of with the words. Okay. So our plane speed and our wind speed. Our final question in this lesson. So this one is very similar to the last one. In the last one, we had a plane that was flying either with the wind or against the wind. In this one, we have a boat that is either traveling with the current or against the current. So it took a patrol boat 5 hours to travel 60 kilometers upriver and 3 hours for the return trip. Find the speed of the boat in still water and the speed of the current. So if it's going upriver, that means it's going against the current. If it's going downriver, it's going with the current. Okay. Which one is faster? Well, with the current is obviously faster than against the current. This is slower. Okay. Now, what are we trying to find here? We're trying to find the speed of the boat in still water and the speed of the current. So those are going to be our two variables. Let B be the boat speed. And let C be the current. So if B and C are our boat speed and our current, if we're traveling upriver and we're going against the current is slowing us down, so our velocity is going to be B minus C. Whatever the boat can do, take away what the current is doing, because the current is slowing it down. If it's going downriver and it's going faster, the current is going to speed up the boat. So it's going to be the boat speed plus the current speed. With that, we can set up our little table here. We've got distance, speed, and time. We're going, let's say, upriver. And we are coming, we got the return trip. Return trip. It is downriver, of course. So again, we always have like these two parts that we can divide our trip in. All right, our distance. Traveling upriver, we travel 60 kilometers. The return trip has got to be the same distance, 60 kilometers. Our speed, if we're going upriver, we're going against the current, we're going slower, so our speed is going to be B minus C. On the return trip, B plus C, because we're speeding up. What about the time? It took it 5 hours to travel upriver, so 5 hours here, and 3 hours to make the return trip. Just like in the last question, we can take that information from the table and develop our two equations, because we know that velocity is equals distance over time. So traveling upriver, our velocity is going to be B minus C. Our distance is 60. Our time is 5. On the return trip, our velocity is B plus C. Our distance is 60. And our time is 3. We can do the same sort of technique for solving as we used last time. 60 divided by 5 is 12. We'll put this one down here. B plus C is 60 divided by 3 is 20. We can add these two equations because the C's are going to cancel out. This is perfectly set up to use elimination here. 2B equals 32. B is going to be 16. Once we know that B is equal to 16, and we know that, let's say from right here, that B plus C is 20. We know that B is 16. That means C has got to be equal to 4. And B and C are our two velocities. So our boat speed is 16 kilometers per hour. Well, kilometers per hour. And our current, our value for C, 4 kilometers per hour. And then we are done.